This video is meant to provide an overview of the learning objectives for our discussions on valence bond and molecular orbital theory. By the end of this series of videos, you should be able to, given a diatomic molecule, determine the type of bond, if the molecule itself is going to be para or diamagnetic, and determine if a molecule will form at all. So if the two atoms will actually form a bond. Given two orbitals, predict the shape of the bonding and antibonding orbitals that will result when they mix. Given a hybridized orbital, determine the orbitals that are used to make it. Given a chemical formula, draw the Lewis dot structure and determine the hybridization of a central atom. Some of the key terms for this series of videos are hybridization, valence bond theory, molecular orbital theory, sigma bond, pi bond, and then the 5 different hybrid orbitals that we will be looking at: sp, sp2, sp3, sp3d, and sp3d2. So why is it that we need to look at alternate theories for bonding if our Lewis bonding theory gives us such good results? Well, oxygen itself is paramagnetic. The image here is of liquid oxygen being poured between two ends of a horseshoe magnet. So you have the plus end and the minus end sitting really close together, and if you pour liquid oxygen between the two, you'll actually get a plug of oxygen forming between them. Paramagnetic material, as we saw with our discussion on electron configurations, have unpaired electrons. Neither the Lewis theory nor valence bond theory predict that oxygen itself is going to be paramagnetic. In order to determine whether atoms are going to form bonds and whether those bonds are going to result in unpaired electrons, things that are paramagnetic, we need to have additional methods or additional explanations for bonding that will enable us to predict these type of phenomena.